Hey everyone, Mr. H here. Gonna try some chapter 3, which is on probability, maybe one of my favorite sections in the book. A lot of cool applications, not just to games, but into lots of statistical research. Basically, you can think of probability as bridging the gap between descriptive statistics and making inferences. Inferential statistics, kind of predicting, making predictions, predicting the future. So here's an example. We'll do some games to get some of the concepts down. We're going to do an experiment where we roll a fair six-sided die and we're going to do it 30 times. Before we do that experiment, what would you expect to occur? Now, if you're not too familiar with dice, here's some pictures of this die. So this is a six-sided die. There are lots of different types of dice with different numbers of sides, but this one's the standard one, six-sided. That means it's a cube, and you roll it, and one of those six sides will come face up, okay? So what would you expect to occur if we do it 30 times? In other words, how many of each one might you expect? Um, so make some expectations. You can jot it down on your own there. There's some space. And then we'll do the experiment. So if you want to hit pause and think about it for a moment, feel free. Otherwise, I'm going to use some simulation in StatCrunch to roll the dice. The die. Okay, so if you want to try this on your own, you can. You have access to StatCrunch. So if just from your MyLab page, if you just click on StatCrunch, open the StatCrunch website, that will bring you to the main StatCrunch homepage, and then you can click on Open StatCrunch, and that's your main spreadsheet, and then it's under Applets. If you go into Applets, Experiment, Roll Die. So there's lots of different ones you can play around with, but we're going to do the roll die one. All right, and then this will just allow us to roll a die. So here we go. Let's do the experiment, and I'm just going to record as I go. Even has some cool sound effects here, right? Randomly tossing a die just to see what happens. Okay, so there's 12 of them. What does it look like happened here? Well, looks pretty good. Looks like we got a little bit of everything, except I guess no fives. Okay, so that's 12 of them. Let's keep on going. I know this is a intense movie we have going here, right? All right, so I'm gonna record these two. Did we get any fives? Yeah, we got some fives going now. Okay, so I guess we're gonna do it 6 more times, and then we've got our 30. All right, and then now we can analyze what we came up with. So I was recording them as they happened, and then I was kind of just doing it with tallies, right? And then recording the number, and that's what we ended up with. So those numbers totaled to 30, and it might, nothing there probably too surprising, right? If you were thinking about this, you probably expected about 5 of each type, right? Because there are six-sided, there's 6 sides and there are 30 rolls, so 30 divided by 6 is 5. So kind of our expectation that it would work out evenly if this is a fair die, that we'd get about 5 of each. Of course, it's not surprising that we don't get exactly 5 of each because there's some variation involved. This last column that talks about relative frequency, what that means is it's a percentage, right? So like, for example, the relative frequency of the 1, I had 7, and then there were 30 total dice. And so then I would just calculate that maybe as a proportion and do some little rounding, you know. So that's a 0.233, right? So approximately 0.233. And I could run through and do that for each one. That's the calculations there. Um, do the results fit your expectations? So that's kind of a personal question. What do you think? And some of you might start thinking about what is probability. Like, what is the probability that we roll a 6, right? What is that theoretical probability? And when we'll get to that, and maybe we'll explore this a little bit further, because what if we roll a lot of times? Right? So instead of rolling the die only 30 times, suppose we roll it 3,000 times. What would you expect to see? Well, we can do that with simulation. If I jump back to my StatCrunch, we can try it. Now, I don't want to sit here and cancel. I don't want to sit here and roll that to their 3,000 times. That would be torture. Okay, so we're back to StatCrunch. Now, instead of using the one I was just doing, there's another one that I can do like a lot of them, and that's simulation. So I'm going to go into simulation dice rolling. And then here I have options. I could do number of sides on a die. I can do any size die I want. And then number of dice to roll. We're still just rolling one die. Not really worried about this tally, etc. thing. I just want to compute it. Gets me to this simulation page, and then I can do 1,000 times, and then another 1,000, and then another 1,000. Okay, and those are the counts. So 3,000 divided by 6 is 500. So I'm kind of expecting to see about 500 for each one. And if I run my cursor over it, you have 488, 491, 528. All of them are pretty close to 500, right? So in the long run, we are seeing that we're getting what we would expect. And that's what probability is. Probability is what you would expect to occur in the long run if you did an experiment many, many times. So in this case, then the probability of rolling, say, a 6 is 1 out of 6, right? 1/6 of the time, you're going to see a 6 come up. Okay, so let's now jump to the handout, and we'll continue with the next page. Where are you? Okay, there you are. Okay, so, and again, this you can fill in on your own. It's more what your expectations are. And so that whole thing was a little experiment just to get a feel for probability. Now we're going to get into some of the vocabulary. So I would definitely read through this on your own when you get a chance, but we can highlight some important things here. We have probability experiment. That's what we just did. An outcome. So if you think about what an outcome is, it's just the result of a single trial. Right? So we were seeing a lot of outcomes in that experiment. A sample space is the set of all possible outcomes. Okay, so for example, in this experiment, there is your sample space, right? One of those things is going to occur. An event is usually the question and the probability, right? Consists of one or more outcomes and is a subset of the sample space. So here's a good example of an event. And that's what we're going to be doing in this section, finding the probabilities of events. What's the probability of rolling a 3, the event rolling a 3? And then more specifically, a simple event is an event that consists of just a single outcome, right? So the event roll a 3 is simple because there's only one way to roll a 3. It's got to come up 3, right? Whereas if I said, what's the probability of rolling an even number? That's not simple because there are a lot of ways to get an even number, 2, 4, or 6. Okay, and then we get to our main formula, theoretical probability formula. this is what you're going to be using when you're calculating probabilities here in 3.1. Number of outcomes in E over the total number of outcomes in the sample space. So a lot of probability, when we do it theoretically, is counting up the possible outcomes. Range of probability. Probability is always a number between 0 and 1, right? The probability of, if the probability is 0, it's impossible for it to occur. If the probability is 1, it's guaranteed that it will occur, and then anything in between. Okay, but you'll never have a negative probability or something over 1 or 100%. Right? Okay, so let's look at some examples. So we've got, and in these examples, we're going to do 3 things. We're going to express probabilities as a reduced fraction, a decimal, and a percent. Those are the 3 possible ways to represent a fraction, a probability, and we'll do all 3 for now. Pay attention when you're doing the homework, how they want the answer. Do they want a decimal rounded to a certain number of places, or a fraction, or what? Okay, so here, a probability experiment consists of rolling a 6-sided die. Are you tired of the 6-sided die experiment yet? We're going to do one more question with it. Find the probability of rolling a 3. Okay, so think about that formula above here, right? Well, how I'm going to write this out, probability of rolling a 3, I'm going to do this, probability of 3, P parenthesis 3. I'm kind of doing this. This is descriptive, right? That's just kind of restating the question in a mathematical, symbolic way. What's the probability of rolling a 3? It equals, right? The probability of rolling a 3 is, it's a fraction. And first we want to figure out, I always like to do the bottom one first, the total number of outcomes in the sample space. In this case, there are 6 of them, right? There are 6 numbers here. And then of those 6 outcomes, how many of them are a 3? There's only 1 3, right? So the probability of rolling a 3 is 1 out of 6. There's the fraction answer. I could get a decimal rounded to 3 decimal places. Would be 167. That's a decimal point. Or I could even write this as a percent. Just a little review, writing things as a percent, you're just dividing by 100, or just moving that decimal 2 places, 16.7%. All right. How about B? Find the probability of rolling an even number. So maybe I'll represent that as P parenthesis E for even. Right. So again, I know 6 is still the bottom number because that's the total number of possible outcomes. How many of those are even? Even is divisible by 2. So that's 2, 4, or 6. There's 3 of them. And this reduces to 1/2. Right? Or as a decimal, that's 0.5. Or move it 2 places for the 50%. So any of those are a valid answer. 1/2, 0.5, 50%. Is the event in part B a simple event? No, it's not, because there were 3 possible outcomes. So when you set up your fraction, if that number up top is not 1, it's not simple, right? So this would be a no. And then finally, how about the probability of rolling a 5 or a 6? So probability of, I could just write it out, 5 or 6. There are 6 possible outcomes. How many of those are a 5 or 6? Well, there's 2 of them. So that reduces to 1/3, which is about 0.333, or 33.3%. All right, that was messy. I'll clean it up when I rewrite these notes. Okay, hope that helps getting things started with probability. It'll get more advanced as we go. We'll do a lot more examples, and we'll go from there. Okay, hope all's well. Talk to you later.